again I have.
Okay. Yes, yes. So what is your question?
No, ma'am. I to follow, I to observe the same sort of thing right from
Yes,
2014, ma'am.
Okay,
My
very good.
solar, my solar mean time, that is noon time is 12:23, ma'am, at Rajmundry.
Yeah. So but I think Rajmundry, is it over or is it still there?
I have resided that, ma'am. No, ma'am. May 7th is the date, ma'am.
Okay, okay, very good. What is your question?
No question.
Okay.
Thank you.
Okay, sir. Okay. So now we'll come on to the activities, right? What are the activities that we are planning that you can be doing? Okay. I will also give you all a copy of the activity sheets so that you can try it out, right? So there's also one other interesting piece of information which I thought was an interesting thing to tell you, that obviously people have been aware of this, right? It's not that people did not know about Zero Shadow Day, etc., right? So, right. So first thing which you can do is, we will talk about this activity, is attitude, right? This is resources which I've got from Dr. TVV. Many of you all may know him. He's from Vigyan Prasad, and we can talk about this activity. So I'll give it over to Sir, and Sir can explain this activity to you.
Yeah, so if you have realized that there are many things which we generally try not to observe and not to be attentive to. Yeah, we take it for granted that sun rises every day in the east and sets in the west. But you should, if you take proper notes of it, observations of it, then you will see that it is not exact east on all days, but it happens twice a day in a year for every latitude. Right. So, just a minute. Yeah. So I'm very sorry. There's a apartment in a building where there are 3-4 cases of COVID, and they need some help. So we are at it too. Okay. So there are some questions here. Yeah. So exact rising and setting in the east, it occurs on different days in different locations, and only from 23.5 degrees east and west, you will see the sunrise and sunset exactly at the east on certain days, and it varies from day to day. 21st March is when you have it on the equator, and again 21st, 22nd March, it can fluctuate a little bit because our calendars themselves, as you know, are not perfect. Yeah, we have that 1.5 day being dropped out every year, adding up in a leap year. So there are many such small corrections which humans make to make their functional life easier. Okay, so now we will see this next presentation where we'll see how to find the latitude, your latitude. Okay, so there is this Shashastha Yantra, which was restored in 1901. And this is an old monument, which was an Indian one, where they use it to find the altitude, the zenith distance of the sun, and hence the local latitude. So zenith we have seen, right? So zenith distance probably I didn't mention, but the distance which you measure from zenith down to where the object is, that's called the zenith distance. So zenith distance is basically 90 minus your altitude of at that place. Okay. So this is, so if you see this building, you must, if people have gone to Delhi, Jantar Mantar, or in Jaipur and many places, we have these old sites which are basically astronomical.
Yeah, this is not getting shared, I think.
Can you see the?
Just ask them.
Could you see the presentation?
No, I don't think so.
No, sir.
No, sir.
No, sir.
Yes, sir.
Now can you see it?
Yes, sir.
Yes, sir.
Yeah, yeah. So okay. So yeah. So finding your latitude. This is what we are going to see. And before we actually come down to our show, that Indian astronomers from a very long time had been building sites and observatories which could measure the time accurately. They could predict occurrences of eclipses, of high tide, low tide, and various things, because these are all related to the astronomical events, alignment of sun, moon, alignment of, basically sun and moon play a big role in our tides, flooding of rivers or oceans, right? And there were a lot of religious practices which Indians were involved in for a very long time. And for them, they had to make very accurate observations to keep the time right. Apart from that, India is an agricultural country. So it was very important to keep track of seasons, change of seasons, time when it's good, time to start the harvest or, remove, right? So they use these stars and their positions and the rising and setting to estimate the coming of ending of summer, start of winter, and so on. Okay, so here is this Shashasthansa Yantra, Shashasthansa Yantra, which was restored in 1901, and it is used to find the altitude and zenith distance of the sun and hence the local latitude. So what we have is a dark room, and you have these two cylindrical scales, and on top of the room there are two holes which we'll just show you. So it's a dark room with two holes on the roof and circular arcs on the two side walls. Okay, and you see there's a picture of the roof. You have these two holes, one here and another one here. And the next slide I will show you how it is done. So this is the same thing with the single hole one. You have the sun, and the sun's position keeps changing, right? So as the sun rays goes through this hole, you can see the sun's image coming on this circular, semicircular arch, right? And there are gradations here, which we shall see. Yeah, there are gradations with which you can see where is it falling and at what angle it is. So when the sun goes overhead, then the shadow will fall directly at the location, which will show that it is exactly overhead. And then it starts moving to the other side. Okay, so here's the our side, and these are the two cylindrical scales, and with on the roof we have two. Yeah, so you see carefully, there are these gradations here. Circular arcs have been scaled on this with degrees, minutes, and arc minutes. So if you see very carefully, we'll share this presentation with you, and you will see that all these are marked very accurately on this. So, and as soon as the local noon approaches, the sunlight which is falling elsewhere starts creeping on the wall. Like you will see here, you can see the sun ray coming here, and it starts coming to the floor. And as time progresses, you notice the sun ray is coming and hitting on the scale. And at perfect noon, this will come. You see how the sun ray is creeping down. These are actual images taken from this location. And you'll see that the image of the sun, that hole in the wall acts as a pinhole, and you can see the sun disk falling here, right? So, and these are gradations on the scale, which will show you the degree and angles in minutes. Okay. And on both sides of the wall, this happens, right? We have two scales, you see, and you see that this sun, image of the sun appears on both the sides of the walls from both the holes. And just only seconds before and after the local noon, the images are formed on both the places symmetrically. See, they're slightly displaced on the right on this scale and slightly on the right on the other one too. But as it reaches the exact noon, they come to the center. Okay. So Jaipur, this is in Jaipur, which is at 26.912 degrees north and 75.7873 east. And on 10th of March 2017, this was done. These observations were taken. And you see 90 minus 30.9. You have to make corrections for the elevation also. And yeah, so on the day the sun is overhead at the equator, you see the altitude of the sun at noon is equal to 90 degrees plus declination minus the latitude, right? So when the declination of the sun is also 90, then this, you have 180 minus latitude. So latitude of the place is actually, yeah, so we are making latitude the subject of the formula, and latitude is 90 minus altitude of the sun at noon plus the declination. So latitude is 90 minus altitude of the sun at noon at the equinox. Equinox, the declination is 0, therefore we are putting 0 there. So at equinox day, for the equator, the latitude will be 90 minus altitude of the sun at equinox, which is 90, and hence the latitude comes out as 0, right? So that's how you find the latitude of the place. And for other locations, we have to, we can calculate what is our latitude by putting in these values. Okay.
This presentation,
so what are the activities which we can do with that now? So Priya ma'am will.
Yeah, so can you see my screen? Can everybody see the screen? Yeah.
Yes, ma'am.
Yeah, very good. So what is to be done? How are we going to prepare for this thing? So, so one thing is you download the ZSD app, which I told you about. And so one simple thing one can do is you take a stick, right? And you put this big sheet of paper, put the stick inside mud, or basically what you need is you need to have a perfectly vertical stick. Okay, the stick should be perfectly vertical. And now you can see that what these kids are doing is they are actually plotting the position of the shadow. I'll give you all the activity sheets also later, but at present I just want to show you in these pictures how are they doing it. So you put the stick in mud, you put paper, and you plot it. What you have to be very careful about is that supposing you started taking the observations, say from 10 o'clock in the morning or 8 o'clock in the morning, then you cannot move the stick or the paper or anything. So you see all these papers, everything is kept in the same position. It should not be disturbed during the readings, right? So your paper has to be fixed at a certain place. This is all fixed, your stick is here. So for the whole 5 hours, supposing you're going to take observations from 10 o'clock to 2 o'clock, right? 4 hours. 2 hours before noon, 2 hours after noon. You are going to keep this at a place which nobody touches and nobody moves. Okay. So you will keep this at a fixed place, right? Is that clear? And try to keep your the stick as vertical as possible. We will then show you ways of making it vertical, but this is one of the things. Now they have put this vertical stick, and let me, okay. So now see here you see this is a blow up of, supposing you put the stick needn't be a stick like that. It can even be, for example, here I have a screw which I have put with Scotch tape. And here I am plotting the position of the shadow at different times, right? So you can see at 11 o'clock, this was the shadow, straight line which shows the shadow. You can take a scale and you can draw the line which has the shadow, right? So this is at 11 o'clock, at 12 o'clock, at 1 o'clock. So you see somewhere over here, this is the noon when it became the shortest. So you are going to this paper, here you see that this paper, they have used a cardboard kind of a paper. Why? Because I don't want the paper to fly, right? I want it to remain in position. You need to be sure that your paper will not move. So then if you're taking some heavier paper, for example, cardboard in this case, the paper is not moving. It's not going to fly. So you are, because this has to be done in open air. So you will accordingly, you can see they are mapping up the shadow positions, right? So they're like, for example, here they have done another way of actually doing it by actually taking a plain glass sheet. This is the sun's reflection and the sun is reflected and coming over here, right? So you can do something like this also. Finally, now another very simple thing which can be done by anybody is, for example, you take a glass sheet. Okay, these are 4 cups, right? Paper cups. You can use paper cup, steel cup, whatever you want. Use anything. Basically, you are going to raise this glass sheet above the white sheet. Okay, and here I have this circular roll. This circular roll can be anything. You can make it. You can. This can be from, you know, from some box which you have, which is circular, right? Now you can see the shadow. See, the shadow is coming like this, right? So this is not zero shadow. At zero shadow, your shadow will come a perfect circle, which I will show you. So for example, you see here you're getting a shadow. These are shadows, right? So this is not yet perfect noon. But if it is perfect noon, then you can look at this. So here, this is another way. Many of you all may have such a glass table in your house. So if you have a glass table like this in your house, all you need to do is keep these round things on top, take it out in the sun. In the down, you keep the white paper and you look at the reflection which you are getting, right? You at zero shadow, perfect zero shadow, you will get a perfect circle coming over here, right? Now here there are many ways in which people to get a perfectly symmetrical shadow. How would you do it? So for example, here he's taken a ball and you can see that the shadow has come perfectly inside this. This is at zero shadow daytime. In this case, you can see is that you have this thing where you have put a string and you put some weight, right? So if you put a string and you put some weight and they're looking at the shadow, this will fall perfectly vertical, right? So I've taken this, you can think up. I want you to think up different ways in which you will do it. And I'll be very happy if you all can send me emails of the photographs of what kind of a setup do you use to actually get this vertical thing, right? It should be as perfectly vertical as possible. I'll show you another interesting thing, which I'll just show you this. This is also an interesting one, which somebody uniquely tried to do that thing. Let me just look for it. Okay, I don't have it. I don't see it over here. But what they did was something very simple. They just took a circular, took a circular stool which had a hole in the center, and you can do it, right? Now, what you are going to do? So what you're going to do is you're going to get your stick or whatever, put that on the paper, and you're going to plot the position of the shadow. Now, what are the computations you've got to get from the shadow measurement? I will show that to you now. So I will also give you all this thing, which is an activity sheet, right? So this is an activity sheet. Okay. I think let me just zoom it a little better. And I need to share it, right? You all can't see it just now. I'll just share it. Yeah, here, this is the one. Yeah. So these are the activities. So the first activity which you're going to do is the determination of cardinal points. What do I mean by cardinal points? North, south, east, west, right? So what are you going to do? You are going to use that stick, right? You can make concentric circles on a plain piece of sheet. Put your stick at the center over here, right? That stick in sundials, it's called a gnomon, Gnomon, right? So what you're going to do is you're going to take this, you place this concentric circles, right? Now what you'll do, this will help you in determining the direction of the shadow at a given location. So what do you do to determine true north? You mark two shadow points, one before transit, one after transit, by taking one of the concentric circles as the reference. So take one concentric circle as a reference point and get the one before and after, right? Then what you are going to do is you'll draw a straight line using these intersection points on the reference circle. From the midpoint of this line, draw a straight line passing through the center of concentric circles. That will be your true north, right? So I have these two figures over here. Here we have these different concentric circles. You are going to take them to actually cut out, mark the 2 points, right? So let's say you mark the 2 points. These are the 2 points A and B, right? Before and after. And what you're going to do is you are going to bisect this, right? You know how to bisect, right? You can use a compass. With a compass, you can bisect it. Bisecting a straight line. I hope everybody knows. If I want to bisect the straight line, how do I do it? I take the compass and I make an arc over here. I make an arc over here. I take the intersection. You see both these arcs, and that will give you the bisected line. Once I know the bisected line, this is my north position, right? Continue the straight line further down, you'll get your south position, right? This will be your east and this will be your west. So that means using shadows. This doesn't have to be done on zero shadow day. You can do it today. You can do it tomorrow. You can do it anytime you want. Basically just using these shadows. So you will find out your cardinal points, right? You'll find out your perfect north, perfect south, perfect east, perfect yes for your location, wherever you are located, right? So please do this experiment before Sunday, where you actually make markings of the shadow of the gnomon, right? Say from 10 o'clock to 12 o'clock, get these 2 points A and B, bisect it, get the point of north. So with this, you will know your perfect north, perfect south, perfect east, and perfect west for your given location, right? So you are going to do this thing. The next thing which you're going to do on zero shadow day, right? Please note the date and the place for your zero shadow day activities. And what you're going to do is when you make that plot, which I showed you, you are going to measure your shadow length. So first here you'll write your gnomon length. I had showed you all in ZSD, it was done for 1 meter, right? But for example, if it is not for perfect 1 meter, for whatever is your length of your shadow, yeah, you are going to plot your, write down your gnomon length and the shadow length at various times, right? And you are note what is the minimum shadow length at what time. So minimum shadow length is your local noon. So this can be done any time day, right? Any day, this cardinal points thing. But on zero shadow day, you will actually say that the zero shadow day was observed at whatever time IST in whatever location, right? So you will fill this and you will know what was the date and time for this. What I'm going to do just now is on this chat box, right? On the chat box, I am going to share this particular this thing, right? I am going to share this particular activity sheet. So please, while the thing is on, I'm putting this activity, that video, that thing also, and I'm also going to put this activity sheet. So please, while the Zoom session is on, you will need to download these, right? So please download the shadow activity and the activity sheet, right? And you will note the local shadow date time. Now, what are we going to do after this? The next thing which we are going to do is we can also use the same experiment to determine the speed of rotation of the Earth. But this will have to be done for places with common latitude, right? So how do we measure this thing? Is that you can actually do this experiment even without observing zero shadow day, directly using the ZSD app, right? So use the Zero Shadow Day app, and for two different places which are at the same latitude, okay? Which are at the same latitude, note the Zero Shadow Day time, right? I hope you all know how to determine same latitude. Once you note the Zero Shadow Day time, you will know the distance between these two places. Supposing this is two places X and Y. These are just examples of two places which are at the same latitude. But you can use that India map to find out different places of the same latitude and whatever is the L. And then you're going to just substitute it in this formula. That the speed of the rotation, very simple, is distance upon time. So you know the distance between these two places in terms of kilometers, and you know the difference in time between their zero shadow days, right? So if it is the time it's exceeding dates, you convert it to how much ever seconds. So either you can get the speed of Earth's rotation in terms of seconds, kilometers per second, or you can do it in terms of kilometers per hours, right? So this is another activity. Like I said, either you all give me your data with which we can calculate it, or you can use the ZSD app itself, right, to find out the speed of rotation, right? The third activity which can be done, for that you will require to have a magnetic compass, right? Many of them already have magnetic compass. If you don't have magnetic compass, another very simple way is, not all smartphones, but many smartphones have compasses in them, right? So you can download a compass app on your smartphone, right? And find out the position of the magnetic north.
Which hospital should it say?
Yeah, you can find out the position of the magnetic north and find the angle between the magnetic north and the north that you have found out using experiment 1, right? And the angle between that will give you the value of the magnetic declination, right? And so using that, you all can do these 3 activities, right? So are there any questions about this? I'll stop the share. I'll start my video. And I hope you all have all downloaded these documents from the chat screen. Yeah, have you all downloaded from the chat screen? Yeah, so please download it. And the activity sheet, right? You can do the cardinal points thing now itself. And the zero shadow day, the same thing you could do on zero shadow day using the cardinal points, right? And the activity sheet, I have shared it on the chat screen, on the chat window. Please, for Zoom, click on chat, and on chat, you will see activity sheet as well as activity.pdf. Yes, did you find it? Amritanshu, can you find it or no?
No, ma'am, it's not visible, ma'am.
It's not visible, but okay, let me do it once again. See, have you clicked on chat?
There is no activity sheet in the chat.
Okay, now I've put it, it's attaching, it's sent successfully. Just look, it says it's sent successfully. And there's another one which
It is
just
still
has
not
the
there.
pictures. It says it's sent successfully. Just have a look. Click on the chat. Mutasir, can you see it?
No, ma'am, it's not there.
It's not there, but I am
It's not
seeing
there.
it. It's telling me that it's sent to everyone.
I can see.
You can see it.
Yes, ma'am.
Yeah, then I don't know why the others are not seeing it. Yeah.
Ma'am, is it sent to everyone or it is sent to
It is
some?
sent to everyone. It's sent to everyone.
Ma'am, the file name is ZSD Activities PDF.
Yes.
One more.
Correct. Yeah.
A zero Saturday activity. These two are we have checked.
Just have a look again. Click on chat and see if you can see it.
Still not there.
I don't know how come, because it's showing me that it's sending it. It's shared it. Click on the chat. Click on chat and you should be able to see it. Okay, all of you all have got emails from me, no? You all have registered for this event? Has everybody registered?
Yes, ma'am.
Yeah, then what I'll do is I'll send it to you through the email also if you can't see it in this chat. I don't know why it's not come, but I can send that to you. So don't worry about it. You will get it, right? Shreyash, you have it. You downloaded it. Very good. Then I don't know why the others cannot
Ma'am,
see
I am
it.
able to see it if I am seeing it from my laptop login. From my mobile, I am not able to see it.
Maybe that's the thing about laptops and mobiles. I don't know. Because I'm also just now sharing it through my laptop. Shreyash, you're using a laptop or a phone?
Laptop, ma'am.
So
Maybe
it's not
the
coming
format
from
is
phone.
different, which is not supported by mobile phones. It is
It is
supported by
PDF. It's
laptop.
a PDF format. There's nothing problem about the format. It's
Then
just
PDF should be here.
It's only PDF. Okay, I'll email it to everybody. Don't worry. I'll just now email it to everyone. Don't worry. I can. So you all have your emails on, right? So what I'll do is just now itself, I will email it to you. So you all will all get it. Okay. So does anybody have any questions? We can check on the questions and the rest we can. I'm just now emailing it to you. So please tell me in case you do not receive it, right, in the email. So that is this.
Ambulance arranged.
So I've just now emailed it to you all. Please have a look at your emails and see whether you've got it or not. Okay. Okay. So this last half an hour I've kept for discussions. Does everybody, is it all clear to everybody? What are the activities to be done? Or do we have any doubts? Very good. Shreyash is the youngest probably amongst all of us, most enthusiastic. And I would request all of you all to please email me what you get, right? So that we can share what we all found out, right? We all have to learn from each other. So please email me whatever you plot and whatever you get. Received email, right? Very good. So everybody's hopefully got the email. In case you have, please register for the event so that I can send you the email. Okay, very good. So I can see everybody's received the email. Very nice. Do we have any more questions? Very good. So do we have any more questions? Yeah, then I can plan another session after Zero Shadow Day.
Afternoon, ma'am. This is Amritanshu. Ma'am, actually, I am a resident of Uttar Pradesh near Kanpur. So I am very well above the Tropic of Cancer. The location being 27 degree in terms of latitude, roughly I am speaking, and 79 degree in terms of longitude near Allahabad. So, ma'am, actually, what I have seen is that is mostly the activities they come into play. They talk about the zero shadow only. So, ma'am, there is one more allied activity which I can be of. Can I be a party in terms of, say, the Eratosthenes experiment, which has been talked about a lot? Because if you can be signed, then I can be Alexandria for you.
Okay, fine. I can sign that. You can send me email and I'll do that. No problem.
Thank you, ma'am.
Okay, fine. No problem. So shall we stop now? And we can meet again after you all get your readings and your data, right? Are there any questions? Does anybody want to ask anything? You can all put on your, let's all at least have a look at each other so that we know. Yeah. Please, everybody, please put on your
Cameras.
cameras. Let's at least see everyone.
Namaste, sir. Hassan sir. Namaste.
Namaste, namaste,
Namaste.
everyone.
Good
Namaste,
afternoon, sir. Good
everyone.
afternoon,
I am
ma'am.
from
I
Rajmundry,
have,
sir.
this is Amritanshu, and I have been attending your classes of the archival astronomy also. And I
Okay,
have
very
learned a
good.
lot from both of you.
Thank you, thank you. Please,
It's a
everyone.
learning process for both of us.
Yeah,
you and
everybody is
us.
learning from everyone. So, the other videos, who else?
Hello, sir. Hello, ma'am.
Hello, sir. Hello.
Assalamu alaikum. Assalamu alaikum, sir.
Sorry, we have we were scattered today. But the neighbors are down with this COVID and they needed oxygen, and we went and set it up, and now they need ambulance. Their houses, many of them are, and they are panicking. So, other ambulances coming. So sorry, we were.
No, but the
scattered.
good news is that at least a neighbor is fine. Since that oxygen cylinder got her oxygen up to 90.